Hello everyone. So in this lecture we are going to talk about how to construct a binary tree using our traversing sequence. In the previous lecture we have discussed that we can traverse a binary tree using three basic methods, that is called pre-order, post-order and in order. Now we can see that if a sequence is given to us, how we can construct a binary tree. So we have one property with the binary tree, that if any of the two sequences are given to us, including the in order traversal, we can easily construct a binary tree. So if you are provided with a in order and the pre-order, or in order and the post order, we can easily construct a binary tree. Let's see. So here we have provided a pre-order. This is one uh, pre-order sequence is given to us for any given tree, and in order sequence is also given to us, and we are interested to draw or construct a binary tree out of these two orders. So how to start? One thing to keep in mind, you must be knowing that how the pre-order works. So already we have discussed that when we talk about pre-order, we usually refer this as node left right, or you can say first we take the root value and then we traverse the left subtree and right subtree. In the in order, we follow this sequence. We go to the left subtree and then we visit the, or you can say print the root, or you can say the node, and then the right subtree. So this is what we are doing. So here we have to first visit this, and then we have to traverse left and right. Here we have to traverse the left, visit the node, and then traverse the right. Okay, so here, if you know, in the case of pre-order, node is first to be visited. Okay, means the very first value is actually referring to the node, or you can say the root of that given tree. So here we will take this A, and in order, this node is coming in between. So the left side is a left subtree and right side is a right subtree. So we can use this property and we will try to identify that where this node is existing in this in order. So you can see that this is existing here. This actually means that this part is a left subtree and this part is a right subtree. And here you can see we have this node, and then we have left subtree. So we have identified that these values, these node values are referring to the left subtree up to H, and this is for the right subtree. This information we have identified or realized by using this property. So this is left and right. So we will start. So we will start constructing our tree. So we have A is at the root node, and then we have a left subtree. In the left subtree, we have these values D, B, G, E, H, and in the right subtree we have C and F. Now again, we have find out that the pre-order is B, D, E, G, H, and the in order is D, B, G, E, H. Now again we will use the same principle of root left right, or left root right. So here we can find out that this is something which is the node, or you can say the root of the tree, and this B is visible here. That means this is the left part, this is the right part. That means if we further proceed this part, you will find that B is going to be the root node, and at the left of this we have D, and at the right of this we have GEH. Here you can see that this is your left subtree and this is your right subtree. Okay, so again we keep on moving in such a way. So we have already finished up to the left subtree, because in the left subtree we have left with only one node and there is no scope to move it further. Now, so we will see this part. Here we have again pre-order is EGH and the in order is GEH. So in the pre-order we know this is NLR, this is LNR. So this is going to be a root. So you can see this is a root, this is a left, and this is right. So that means this is going to be root, and then this is left, and this is right. So we have already identified that which node will take place in this left subtree. Now how to adjust this node in the right subtree? So just we go this here. So you can see here that in this part, in the pre-order we have CF, and in the in-order we have CF again. That means this is your node, this is your root, and then we have just write it here. This is NLR, this is LNR. If I am calling this as a root node, so this becomes a root node, and here we don't have any left child, we have this right child. So that means this will be the root, and F becomes the right child. So I am going to construct a tree now in a proper way. So our tree will be A, B, D, E, G, H, and this is C, and this is F, and this is our required binary tree. Okay, so we have seen that how to construct a binary tree using a pre-order and in-order. In the similar way, we can also construct a binary tree if instead of a pre-order we are provided with the post order. So I am taking the same example for this. For the same tree, I have given a post order and also the in order, and then I will construct this tree. So let's see how the things will work. So this is the thing. This is given here, post order and in order. Just keep in mind that this is the tree that we get. So ABD, just keep this figure in mind, because this is the tree that we are going to get it again when we do the next question. Okay, so in the post order, we follow this rule, which this is left, right, and then we have the root, and in the in order we have left, node, right. So keeping in mind this sequence is actually given in the post order format. That means the root, or you can say the node, the root node will be appearing at the last. That means this will be going to be a root node of the entire tree, and this is in order where this root node is appearing at somewhere in between. So you have to find out where this A appears. So A is appearing here. That means this part is actually the left subtree, and this is the right subtree. So if you look at the sequence, then you can see that this up to this much is your left part, which is a left subtree, and this is your right subtree. So we will now draw our tree. This is A, which is actually the root node, and then we have a left child. This is D, B, G, E, H, and the right child is C, F. So here you can see that post order is D, G, H, E, B, and your in order is D, B, G, E, H. Now keep in mind this sequence, whenever we proceed, we always refer to this, you know. So here we have seen that this is node is always at the rightmost. No value is actually the root node. So we can see that this appears here. That means this is your left and this is your right. So if you look at this is your left and this is your right. So here you can make this is your B, and then you will get D here, and at the right you will get G, E, H. So now there is no scope to extend further, because this is the only node. Now we have to move further to the right child of this. So post order we have to write, which is actually, so if you look at here, this is G, H, E, and the in order is G, E, H. And here you can see that this is your root value. This is the root value. So this is the left and this is the right. So you can write here E. This is your G and H. So we have already processed our left subtree. Now we have to see that how we can construct the right part of this required tree. So you can see here, this is FC. So in this post order, this is FC, and in the in order, this is CF. So you can see that this is the rightmost element. This is the rightmost node which is acting as a root. So here you can see this is a root. That means there is no left child. We have a one right child. So you can make it like this. So finally, when you construct your means final tree out of this figure, you will get A, B, D, E, G, and H. And here you can get C and F. And this is the same tree that we have got earlier, and this is the same. If you look at this, this is the post order of the same tree that we have just solved in the previous example. So here we have seen that we can construct a binary tree if we are provided with the two combination in order with pre-order or in order with the post order. Okay, so now let us take one more example. We will take one tree, we'll drive the in order, post order, pre-order sequence, and then we will trace it back the same tree. So let's see. So let us take one tree, any tree. I am going to make one tree, and later you can also just draw any tree, binary tree, and then convert into the pre-order, find out the pre-order traversal sequence, and then the post-order sequence and the in-order sequence, and then you can try to get it back the same tree. And this you can do for your practice. So let us take, this is one tree, A, B, and then let's say we have F, and then we have G here. Let's say here we have C, D, and E. So what we will do, this is binary tree, and we will first find out what is the in order of this tree. So to find out the in order sequence, so to get in order sequence, you have to keep in mind that in order means we are looking for left node right. Okay, so that means you have to keep on moving towards the left. So we have to start from the root. We look to the left, and again this is your subtree which is acting as a root here. Then you go to left, again the subtree, we have to go left here. So there is no left child. So left is processed, you go to the root, that is node, and then you will print this, and then you go to the right. So we have already processed this. So left has been processed of this particular subtree. Then you go to the root, that is B. So this tree is again processed. So left has been processed. You go to the node, that is A, and then you go to the right. But again, when you go to the right, this is again a new tree given to you, and then you have to go to the left. So left is D, and then you go to the node. This is the node for this tree. So C and E. So this is the in order sequence for this given tree. Similarly, we will find out the, let's say, pre-order sequence. So pre-order sequence means we are finding the sequence in this format: your root node, then left, and then right. So you will get A, and we will get A, then B, then F, then G, then you go to your C, and then D and E. So this is what we have get. So just we will write here the pre-order. Let us write here the pre-order sequence. This is A, B, F, G, C, D, E, and in order sequence is F, G, B, A, D, C, E. Now we will be now our objective is to get our binary tree. So we will use our previous approach, and we will check that are we able to get this tree or not. This is what we are trying to do. So pre means node left right, and this means left node right. So here we know that the very first element, the very first value refers to the root of this tree. So A here, and that is A is existing here. That means this is your left subtree, this is your right subtree. So these are the nodes that is a part of left subtree. These are the nodes which is a part of right subtree. So you can see here that these refers to the left subtree and this refers to the right subtree. So you can construct your tree A, and then in the left side we have F, G, B. In the right side you have D, C, E. Now again, uh, like we did in the previous example, so in the left subtree we have B, F, G, and in the in order we have F, G, B. So here you can easily see that this is your uh, root node for this left subtree. So it is occurring here. That means this is your left part and there is no right child. So that means you can uh, make this B, and for this B we have F and G as a left child and there is no right child, right? Now if you look here in this is in the pre-order we have node left right, so this is all left and there is nothing right here, right? So you can again proceed. So in the pre-order we have FG and in the in order we have FG. So this is going to be your root node. This is root node. There is no left child, this is your right child. That means F, and then you are going to make G right child. So we have already processed the entire left subtree. Now we'll move to the right subtree. So in the right subtree, what you will notice that this is in the pre-order, our sequence is CDE, whereas the in-order sequence is DCE. So we know that this is our root node. So that means this is a left child, this is a right child. So you can simply make it C, and here you get D, and you get E. So if you make it means here means clearly out of this given structure, what we get? We get A, B, then we get F, and then we get G, and here we get C and D and then E. So we have seen that this tree and this tree is the same tree, and we have already means practiced and checked that if any pre-order and in-order is given to us, we are able to construct a binary tree. So this is all for this lecture, and we will see more properties in our later lectures. Okay, so take care. Thank you.